So far, you've dealt with trig ratios in a triangle. That's all you've done, okay? So this unit discusses trig ratios of angles on a coordinate grid, the XY axis. Such angles are in standard position. Always, the initial arm lies on the x-axis just like this, and the terminal arm is what ends our angle. So if this is approximately, I don't know, to go from there to there is 90 degrees, so this might be approximately 60 degrees, roughly. So our terminal arm is there, our initial arm is there, and that's our theta. The way we number these is this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? So let's just get some practice drawing angles. Special note, angles can be positive or negative. Positive angles are drawn this way, counterclockwise, and negative angles are drawn clockwise. Okay, come on. Okay. Draw the following angles in standard position. So if they're in standard position, we draw our x and our y axes just like this, x, y, and 30 degrees would be approximately 1/3 of the way to 90, and there's our terminal arm. So here's our terminal arm. Our initial arm is here, and this is 30 degrees. Okay? Yeah. No, you estimate. Just get it as close as possible. Okay, let's do, guys, just a reminder, I am recording. Let's draw 315 degrees. So that is going to go, again, we're drawing them in standard position. This is 180. This is 270. Now to get to, if this is 270, to get to 315, we have to add 45 degrees. So it's approximately there, 45 degrees. So this is 315 degrees. I want to point out a new term that will be important for you tomorrow. There is, do you see this angle here? Right here? Between the x-axis and the terminal arm? This angle here is called the related acute angle. Okay? The angle between the terminal arm and the x-axis is called the related acute angle. And I'm just going to point them out today, just so that you get used to the term, okay? Our 315 degrees is this angle here, but 315 degrees has another angle called the related acute angle, and the related acute angle is 45 degrees, okay? Let's do 630. Well, this is 360 degrees, not quite there yet. 360 plus 90 will get us to 450, plus 90 will get us to 540, plus 90 will get us to 630. Okay? Because it lies on the x-axis, its terminal arm, like this is the initial arm, the terminal arm here, this is called a quadrant angle. Because its terminal arm ends up on either the, well, any quadrant angle, the terminal arm lies on the either y-axis or x-axis, okay? This is in effect a quadrant angle. Now minus 270, we're going in a clockwise direction. So we're going minus 180 plus minus 1 plus minus 90 gets us to minus 270 degrees. This is another example of a quadrant angle because its terminal arm lies on one of the axes. So in this case it lies on the y-axis. Can I explain anything better here? Okay. Now you have to get used to drawing radian measures. Okay? So, how many degrees is in 5 pi by 6 radians? You don't really have to know that because do you oh, did I? I'm sorry. Oh, minus 720? Okay. Thank you for pointing that out. So, this is going to be minus 360, right? We're going to have to go another minus 360 to get to minus 720. Uh-oh, this is minus 720 degrees, and it's going in a clockwise direction. This is another example of a quadrant angle because it ends up on the x-axis. So the two terminologies we've learned today is quadrant angle, and you've also learned related acute angle in addition to angles in standard position. Okay, let's look at radian measure. If I were to go, I'm just going to get a, if I were to go from here to here, how many radians is that? Pi radians. Pi radians goes from there to there. Now 5/6 pi, let's just see how we do that. Let's break this up. Pi by 6 is 30 degrees. So this is going to be 3 pi by 6 if I get to there. Let's just break this up into 6. 1, 2, 3, 4, 5, 6. Okay, so 5 pi by 6 is 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6. That's 5 pi by 6. Just so you know, that's 5 pi by 6, right? You just break it up, just break up pi radians into 6 parts. The related acute angle here, RAA, is equal to pi by 6 radians. Yes. Okay, this one, the angle is just 30 degrees. It doesn't really have a related acute angle because the related acute angle is itself for 30 degrees, right? And for quadrant angles, there's not a related acute angle. Okay? So there's a related acute angle. They're all quadrant. You'll see the reasoning tomorrow when we try to find the trig ratios of quadrant angles, and the trig ratio of 5 pi by 6 you will see depends on its related acute angle. Okay, so it'll make more sense tomorrow. 3 pi by 2. Okay, if that's our x, that's our, this is pi radians, right? This is 2 pi by 2, 3 pi by 2. Again, a quadrant angle. This is 3 pi by 2 radians. Okay, this is 2 pi by 2 or pi radians. We have to go another half a pi radian to get to 3 pi by 2. 9 pi by 4. Well, pi by 4 is equal to 45 degrees, right? So let's just divide this pi radians into 4 parts and this into 4 parts. So this is pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, which is pi, right? 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4 is 2 pi radians, which is 360 degrees. Now we come up to 9 pi by 4 radians. The related acute angle for 9 pi by 4 radians is pi by 4. Okay? Right? Pi by 4, 2 pi by 4, 3 pi by 4, 4, 5, 6, 7, 8, 9. The related acute angle is between the terminal arm and the x-axis. This little angle here is pi by 4 radians. Oh my, minus 37 pi by 6. Fine. Okay, ready? Minus 12 pi by 6, right? Minus 2 pi radians, minus 12 pi by 6. Minus 24 pi by 6. Minus 36 pi by 6. Now we need one more pi by 6 to make it minus 37 pi. So divide it up into 6 parts, right? We're just going to take it there. The terminal arm is approximately there. Does anybody want me to do that one again? Right? Always remember this is 2 pi, negative 2 pi, right? So if this is negative, that's the same as negative 2 pi is equal to negative 12 pi by 6, right? Agreed? That's so just doing it again. Negative 12 pi by 6. 2 times that is negative 24 pi by 6. 3 times that is negative 36 pi by 6. So this is negative 36 pi by 6. We just need one more pi by 6. Okay? Those are angles in standard position. Now we're going to do the trig ratios of angles in standard position. Ready? We're going to fit this in the best we can. We're going to note some interesting stuff here. Let's try to divide this up evenly. I guess we'll go we're going to try to make room for everything. It's a tight squeeze, but I want you to see an important relationship. Let's first of all, the coordinates of a point on the terminal arm of an angle theta in standard position are given. Okay? Determine the exact trigonometric ratios for theta, then find theta. Fine. Let's just draw a small diagram here because we need to find room for the 6 trigonometric ratios. But we're going to see an important, notice all the points are the same except the signs are different. Okay, that's an important point. So, this is x, this is y. Okay, if we were to estimate 2, 3, let's say 2, 3 is there. Well, I'm going to put it up a little bit higher because we need just a little bit more space. We're going to draw right, this is the angle. That's our theta. Do you agree if this is the point 2, 3, this is 2 and this is 3, right? X value is 2, the height is 3. Can anybody tell me what this is? What is the hypotenuse here? Our hypotenuse is square root of 3 squared plus 2 squared is 13. This is root 13. Agreed? Okay. So, tell me, what is the sine of theta? Opposite over hypotenuse. 3 over root 13. Rationalize the denominator. So far, so good. Cosine of theta. 2 over root 13. Rationalize the denominator. Tan of theta. Opposite over adjacent. Cosecant theta, the reciprocal. Perfect. Secant theta. Cotan theta. Are we good with this? Good? I hope so. You're going to find an interesting relationship going right across here. Okay? And that's what I want you to see. Okay, let's draw this. Oh, if we were to plug this in our calculator, theta equals inverse sine of 3 over root 13, and that is approximately 56.3 degrees. Okay? If you can just take my word for that. And there's going to be an interesting relationship between the angles. In order for you to understand tomorrow's lesson, you need to see the patterns we're developing here. Okay, let's draw it. Now it's negative 2, 3. It's about there, approximately. Oh, that should be a 3. I don't know why I put root 3, because I'm thinking of root 13. But let's put a 3 here. And this is going to be, even though this is a negative, well, negative 2 squared is 4, plus 3 squared is 9. 4 plus 9 is 13. This 2 is root 13. Okay? Now, this is our angle theta here. Okay? This is our related acute angle, but this is our theta. And I'm going to point out these relationships here. Can you tell me what sine of theta is? Sine, even though this is our theta, our trig ratios for theta depends on the related acute angle. So sine of theta is what? Notice, the trig ratio is equal. The trig ratio is equal, but the theta is different. Okay? However, the trig ratio is equal. All right? Cos theta is going to be adjacent over hypotenuse. Notice these two ratios are equal in magnitude but different in sign. The only difference between this and this is the sign. Okay? Tan theta is equal to opposite -3/2. Notice, same magnitude, difference in sign. Cosecant theta is the reciprocal √13/3. Also, don't forget to rationalize the denominator. And this one is secant theta and cotan theta So, what I want you to notice right now, the numerical value or the magnitude of the ratios for these two angles, this one and this one, are the same. The difference is the sign. Very important for you to realize. And do you agree that this related acute angle and this related acute angle are the same thing? Do you agree that both of these have the same related acute angle? That this angle in here, this angle in here, this related acute angle here, and this one here are equal? Yes. Yes. And that's why, how do you think I can find this theta? What do you think this theta? I can find this theta because I know this theta. You see the pattern. So the theta here equals 180 minus 56.3, and that is equal to approximately, they're both approximate because 56.3 is 123.7 degrees. Makes sense? And that's because they have the same related acute angle. I can now, if I know this guy, I can find three more angles based on this related acute angle. Okay. Oh, I'm so happy you're seeing this pattern. It's so important for the cast rule tomorrow. Let's do this guy. And the hypotenuse is always positive. It's still √13, but just the signs of x and y are different. Are we good? Okay. Do you agree sine theta? What will sine theta be in this one? Perfect. See how you can compare? Down here it'll be negative because it's a minus 3 over positive root 13. Cos theta. Will cos theta be negative? Tan theta. Will tan theta be negative here? Right, because negative 3 over negative 2 equals positive. The reciprocal. Will be negative root 13 over 3. Secant negative root 13 over 2. And cotan, it'll be positive 2 over 3. Now, do you agree that this related acute angle is the same as this one is the same as this one? So what's theta? So it's 180 plus 56.3, which is approximately 236.3 degrees. Good? RAA equals 56.3 degrees. RAA equals 56 point. This one is just 50. It's not really an R. It's already an acute angle. It's not a related acute angle, okay? So let's do this one. One more just to drive it home. Ready? Will sine theta be positive or negative here? Cos theta, positive or negative here? Tan theta, positive or negative? Now we do the reciprocal. All right. Notice. Noticed. Cosine was positive in this quadrant. All of them were positive in this quadrant. Sine was positive in this quadrant. Tangent was positive in this. This is the cast rule. In this quadrant, cosine and its reciprocal were positive. In this everything else was negative. In this quadrant, tangent was positive. Tangent and its reciprocal was positive. Everything else was negative. Right? C-A-S-T. In this quadrant, sine and everything else, sine and its reciprocal was positive, everything else was negative. Sine was positive here, right? Here they're all positive. All of them are positive. What's this angle here? What's our theta in this angle? 360 minus 56.3 degrees is equal to 303.7 degrees. That's our... No, you subtract it from 360. You go 360 minus 56.3. This is 56. Here. You need a bigger diagram. The related acute angle, when we come down here, the related acute angle is 56.3. The angle between the terminal arm and the x-axis is 56.3. So we go 360 minus 56.3. The trig ratios of this angle is dependent on the related acute angle. Was this clear? Notice, the ratios are the same. The signs are different. If an angle has a terminal arm in this quadrant, in quadrant number 1, all of them are positive. If the terminal arm is here, sine and its reciprocal are positive, everything else is negative. If the terminal arm is here, tangent is positive, everything else is negative. If the terminal arm is here, cosine is positive, everything else is negative. So cosine is positive here and here. Sine is positive here and here. Tan is positive here and here. It all depends on the related acute angle. The related acute angle is always measured against the x-axis, not the y-axis. So 45 degrees. 135 is here, but it depends on the related acute angle of 45 degrees. 225 ends up here, but it depends on the related acute angle of 45 degrees, which is measured in accordance with the x-axis. Then 315 ends up here. That's 315, but we get the trig ratios from the related acute angle, which is against the x-axis, or 360 minus 45 equals 315, right? This is our related acute angle, 45. We will go over it again tomorrow. Okay, let's keep going. Look at how much more we have to do. Okay, let's do it. Let's just do it. If you understand this, you'll be able to get this. This is telling you tan C is equal to negative 5/7. It falls in the second quadrant. Well, if it falls in the second quadrant, we know it goes, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Castrol, C-A-S-T. You know tan here is negative. You know tan is opposite over hypotenuse. This is the related acute angle. This is C, but our related acute angle is here. Opposite is Oh, sorry. This is opposite over adjacent. My bad. This is opposite over adjacent. So, opposite is opposite over adjacent equals negative 5 over 7. Since we're in this quadrant, the 5 must be positive because this is above the x-axis, and negative 7 is here. So, what is our hypotenuse equal to? Square root of what? Which is 74. Hypotenuse is always positive. We only worry about the signs here. Either x or y is positive, or in this case y is positive, x is negative. So, sine of C is equal to opposite over adjacent. Sorry, opposite over hypotenuse. So it's going to be 5 over root 74, and that's 5 root 74 over 74. Cos C is equal to minus 7 over root 74. That's negative 7 root 74 over 74. Tan of C is 5 over 7. Notice, the CAST rule tells us sine is positive, everything else is negative. This is negative 5 over 7. Now you can do the reciprocal, which is easy enough. Root 74 over 5. Secant of C is equal to negative root 74 over 7. Cotan of C equals negative 7 over 5. So, we have to go when we go the related acute angle we find by going inverse sine of 5 over root 74. However, C will equal 180 degrees minus the inverse sine of 5 over root 74. When you plug this into your calculator, you get the related acute angle. Right? When you plug this into your calculator, you will get the related acute angle. But C will equal 180 minus the related acute angle. I know you need time to absorb that. Are there any questions? See, when you go inverse sine of 5 over root 74, you get the related acute angle. You don't get C. So in order to find C, we have to go 180 minus the related acute angle. 180 minus the related acute angle. Can I leave that one for you to do by yourself? Well, I'm just going to finish the lesson, okay? Okay, what does A equal? Well, the related acute angle equals And angle A will equal 180 plus 53.1, and that will equal 233.1. I'm giving you the answer when you do it by yourself, okay? But I want you to try this one by yourself. We will review Castrol tomorrow. Okay. R is another symbol for hypotenuse. On a related acute angle, on angles in standard position, we refer to the hypotenuse as R. Okay? Now, do you agree that sine is y over the hypotenuse or y over r? Right? Because we have coordinates, right? Wasn't sine of theta equal to y over r, the y value over r? Cos of theta was the x value over r. Tan of theta was y over x. Same thing here. Sine theta is y over r, cos theta is x over r, tan theta is y over x. These are the reciprocals. Now, when we deal with quadrant angles, 0, 90, 180, 270, 360, 0 lies here, 90 lies here, 180 lies here, 270 lies here, right? 270 is this angle. 360 lies here. We use very simple points to find the trig ratios of quadrant angles. 1, 0, 0, 1, negative 1, 0, 0, negative 1. So watch. The sine of 0, do you agree if, let's see, for 0, r squared equals 0 squared plus 1 squared. R squared equals 1. R equals square root of 1 is 1. We always take the positive. R will always equal 1, right? R squared, for 90 degrees, R squared equals 0 squared plus 1 squared. R will equal 1. R always equals 1. Now it's easy to find the trig ratios for 0, 90, 180, 270, 360. For 0 degrees, y is 0, r is 1, and that equals 0. The trig ratio for 0 degrees is 0. So, the trig ratio for cosine of 0, right? Cosine of 0 is going to be 1 over 1, and that equals 1. The reciprocal of sine is 1 divided by 0. This is undefined. The reciprocal of cosine is 1. The reciprocal of tan is 1 over 0. This is undefined. So, for 90 degrees, the y value is 1, r is 1, this equals 1. Cosine, 0, x over 1 equals 0. Tan, 1 divided by 0 is undefined. Cosecant, reciprocal of 1 is 1. Reciprocal of 0 is 1 over 0. This is undefined. And tangent is, the reciprocal of undefined is 0. right? 0 over 1 is 0. What was undefined, its reciprocal is now 0. So it's 1, 0, undefined, 1, undefined, 0. Okay, just double check. 180. The y value is 0. 0 over 1 equals 0. Negative 1 over 1 equals negative 1. Y over x is 0 over negative 1 is 0. Reciprocal, 1 divided by 0 is undefined, right? The reciprocal of negative 1 is negative 1. Reciprocal of 0 is undefined. Here. Reciprocal of negative 1 divided by 0 is undefined. Reciprocal of cos is negative 1. This is undefined, undefined. Similarly with 270, the y value is negative 1 divided by 1 is negative 1. 0 divided by 1 is 0. Y over negative 1 over 0 equals undefined. Reciprocal of negative 1 is negative 1. Reciprocal of 0 is undefined. And reciprocal of negative 1 over 0 is 0 over negative 1. And that equals 0. 360 is the same as 0. Right? 0, 1, 360. 0 degrees and 360 degrees have the same terminal arm, so their trig ratios are equal. Undefined, 1, undefined. Sine of 0 degrees equals sine of 360 degrees, right? Sine of cos of 0 equals cos of 360. They're just equal. They have the same terminal arm. They have the same trig ratios. Finally, two angles are coterminal if they have the same initial arm and terminal sides. So, suppose I have a 45 degree angle. If I went 45 plus 360, that equals what? Notice that 45 degrees and 405 degrees have the same terminal arm. That means they have the same trig ratios. If I were to go, let's say this is 135. If I went 135 plus 360, they would have the same terminal arm. That adds up to 594. These two are coterminal angles. They have the same terminal arm. That means 135 degrees and 495 degrees have the same trig ratios. That's why. Now, if we measure in radian measure, we have to add 2 pi. Right? These two angles will have the same terminal arm. So that will be 5 pi by 6 plus 12 pi by 6 equals 17 pi by 6. 5 pi by 6 plus 4 pi will have the same terminal arm because 4 pi is 2 complete revolutions. That equals 5 pi by 6 plus 24 pi. Right? I'm adding. Does everybody see that? We don't see it. Okay? Watch. Okay, watch. 5 pi by 6 is here. If I add 2 pi, I have the same terminal arm. So 5 pi by 6 plus 2 pi by 6, 2 pi is equal to 5 pi by 6 plus 12 pi by 6 equals 17 pi by 6. So 5 pi by 6 plus 12 pi by 6, they have the same terminal arm. Hard, eh? Is this okay? Is this better? But if I have 5 pi by 6 and add 2 pi, 4 pi, I have the same terminal arm. Similarly, I can subtract 2 pi. 5 pi by 6 minus 2 pi equals 5 pi by 6 minus 12 pi by 6. That equals minus 7 pi by 6. 5 pi by 6 minus 4 pi by 4 pi, equals 5 pi by 6 minus 24 pi by 6. That equals negative 19 pi by 6. All of these have the same terminal arm. All these angles, they will all have the same trig ratios. All of them. If we have degrees, it's plus 360. We could go 50 degrees plus 720 degrees. We could go 50 degrees minus 360. We could go 50 degrees minus 720. All of these have the same terminal arm. They all have the same trig ratios. I know that was a long lesson. A lot to learn. Thank you for your patience. Right now, guys, do this one, and I'm going to walk around and answer any questions you may have.